Reclaim is protecting the environment and public health. Today on this video, we will be discussing about the potential effects of silver on wastewater treatment plants and what are some of the research being done on this. Also, we will discuss the use of predictive models to design better wastewater treatment plants and how these predictive models can be used to protect public health. First, we will talk about silver nanoparticles. These are just nanoparticles made out of silver, and these particles are between 1 nanometer and 100 nanometers in size. What are some of the uses and sources of silver nanoparticles? From industry, we get silver nanoparticles on the surface of household appliances because it's been used as an antibacterial. In the medical field, we see silver nanoparticles on air filters, bed linens, and surgical instruments. On the domestic side, we can see silver nanoparticles on fabrics, antibacterial soap, and washing detergent. What are the dangers of silver nanoparticles? For human health, it can cause argyria, which is a discoloration of the skin. It turns blue. For the environment, it can affect fish, algae, and it can be bioaccumulated on these species. For wastewater treatment plants, it affects the bacteria that it's important for the secondary treatment. Now, we will have the PhD student, Emma Clark, from the University of Exeter, explaining us a little bit more about this topic of silver nanoparticles.
I'm currently working on researching the fate, transport and behaviour of silver nanoparticles through wastewater treatment works. I'm primarily focusing on how the nanoparticles themselves are affected by exposure to wastewater treatment systems. So looking at how the wastewater treatment environments can actually change the particle state, any key characteristics of the nanoparticles, and also its chemical speciation. Now this is important for wastewater treatment processes, but also wider environmental concerns, because silver in different speciation states can have differing toxicity impacts. So, for example, the toxic effects of silver ions and silver nitrate are known to be highly toxic to bacteria, to phytoplankton, to fish. We're also looking to see where within the treatment processes they're being retained, or if they're just going right through the treatment process and into the aquatic environment as part of the liquid discharges. The main concern, however, is the environmental effects. So where we know that silver ions are highly toxic to phytoplankton, bacteria and fish in the aquatic environment, it's necessary to better understand the toxicological impacts of silver nanoparticles on receiving water systems.
Thanks to Emma for that explanation on the risks of silver nanoparticles. Now, we will have a brief discussion with Dr. Andrew P. Duncan from the University of Exeter about the use of predictive models for the protection of public health and improvement of wastewater treatment plants.
What does my work relate to? It relates to the use of artificial neural networks for early warning systems in hydrology and the environment. I'm currently working on a project to improve wastewater treatment and indeed to reuse the effluent from the wastewater treatment in India. How I'm proposing to kind of overlap with the neural network work is that the actual process of training neural networks that I used evolutionary algorithms, which is a nature-inspired way of optimizing a problem. And in wastewater treatment, what you have is a treatment train with different processes, and each of those has a choice to do with what options there are for those treatment processes, and also there are other factors that are inputs to the process of designing and optimizing. And ultimately you want to optimize not only for the minimum cost, both in terms of capital and running costs, but also minimal environmental impact and minimal social consequences of the work that I've done on using the artificial neural networks for testing of bathing water quality at beaches in the UK. Essentially, it's a kind of rolling program of monitoring of water quality at beaches. So the idea is to use various environmental factors such as antecedent rainfall, salinity, and possibly several other factors that will allow a predictive model to be built that minimises the false positives and false negatives of deciding whether or not it's safe to swim on any given day at any given beach.
Now we have a better understanding on the effects of silver nanoparticles on wastewater treatment plants and how new technologies and methods can be applied, like predictive models, to further protect public health and improve wastewater treatment plants. Thank you for your attention, and don't forget to follow us on Twitter and like us on Facebook.